Welcome to the first episode of 10 or Less, the educational podcast series where I take a boring chapter from a textbook and turn it into a video 10 minutes or less. Today we'll be looking at renewable energy resources and environmental science overview. All the material has been adapted from the G. Tyler Miller textbook, Living in the Environment, the 15th edition. This is a textbook that is recommended and suggested by CollegeBoard as one of the best textbooks that they have in order for students to study for their AP Environmental Science test. So I figured, hey, if it works for AP Environmental Science kids, it works for my kids. Today we'll be looking at 6 of the most common renewable energy sources out there. There's a lot more than 6, but the 6 most common ones are the ones that everyone knows about or at least heard about. So we'll be taking a look into what they are, what it means, and some of the more interesting positives and negatives that you may not have thought about each of these energy resources. So without further ado, let's head into the first one. Solar energy. Now, solar energy is a utilization of the sun's energy to power and heat. When I say power, it means to generate electricity. And heat, well, means to heat. We do this through 2 main methods, passive and active methods. A passive method of using solar energy is simply absorbing the sun's energy without using pumps or fans or any other fancy gizmos. This can be something simple as opening your windows to let sunlight in to warm your room. Very simple. Easy. Or you can even step outside to enjoy the nice sunlight. That's passive. Active methods involve diverting that energy, distributing that energy, moving it around using those pumps and fans and fancy gizmos. So, what are some of the benefits? Well, first of all, energy is free. You can't really place a price on the sun. Net energy is moderate to high. Now, when I say net energy, it basically means how much energy you're getting out, subtracting the energy it took you to get it in the first place. So let's say a passive method of getting solar energy. How much energy did it take you to walk up and open the curtains? Not so much. But now you have a lot of sunlight coming through, warming your room up, so you feel nice and cozy. So net energy is high because you expended very little but got a lot more in return. Next, quick installation. They're really easy to install. You can pick them up from the depot shop and stick them on your roof. Really simple. They don't emit CO2 and they have very low air and water pollution, and they don't disturb land as much because you can place them pretty much anywhere you have walls or rooftops. So what are some of the downfalls? Well, first of all, you need to heat the energy somehow. Once the sun goes down, you don't have that heat, or you don't even have the energy because the sun's gone. So you need access to the sun at least 60% of the time, or else you might not have stored enough heat to survive for the rest of the night. And the sun might be blocked, and, well, active collectors, they look kind of bulky, they don't look kind of clumsy, not the best thing to have on the top of your roofs. In fact, you might want to replace them with Santas and snowmen during the wintertime rather than having big, bulky things collecting sunlight. And if they break down, you have to fix them. So that's solar energy. Next, let's look at water power. Water can be used to turn generators and turbines and create electricity. This is known as hydropower, hydro meaning water. It's one of the main leading sources, and because it only requires that you have moving water, it's actually very easy to use. The best way we use it, the most common way we use hydropower is actually through dams or man-made waterfalls that we can use to turn that kinetic energy of the falling water and to turn turbines and generators. First, it's very efficient. They have a long lifespan and they create lots of energy. And because they create lots of energy, electricity is very cheap when it comes to hydropower. They provide they produce little to no CO2 emissions, and they also may provide flooding control for those downstream below the dam. This also provides year-round water because you have a nice big reservoir, and that reservoir can also be used for fishing. Bad things. It upsets people. If you want to build a dam and you want to have a big reservoir, you have to kick them out. Next, the dam might break down. It's very expensive to build, and the very first time you build the dam, you have to create a lot of pollution because you're destroying the surrounding cliffs, surrounding rocks in order to place that dam in there in the first place. And that's hydropower. Next, we got wind power. Wind power, in the same way you use water to turn turbines, we can use winds. You can be placing them along hills or other windy regions, and as the winds blow, windmills start spinning, turning the turbines inside them to generate the energy that we can use. So, windmills, very efficient. Next, they don't produce any CO2 because windmills aren't burning. In fact, they're just turning. Next, you can build them at sea. You don't have to use land, so we can save the precious land resources we've got and put them out in the ocean. They produce very cheap electricity and are actually very easy and quick to construct. A quick note about very high efficiency. Did you know that it only takes about 4 months for a windmill to pay for itself? Think about that. But here are some of the problems. First of all, you get the visual pollution. If you have a nice view, you don't want it to be polluted with a whole bunch of windmills, unless you're into that kind of thing. But not everyone is, so we have to be considerate. Next, you need to have wind. It may kill or injure migrating birds, and if there is no wind, you need to have some sort of a backup system. So those are some of the benefits and drawbacks of wind power. Let's look at biomass energy. Biomass energy is actually one of the most oldest forms of renewable energy that humans have used. Biomass counts as everything we can burn that comes from a biological source, such as trees, twigs, cow manure. And we can consider these, even though we're burning them, as renewable because compared to our lifespans, they actually grow back in a short amount of time. We can't turn dead trees into oil, but we can turn algae into biofuel. First, moderate cost, not too expensive, and you have a lot of potential in some areas. And you can make use of agricultural and urban waste products. You don't want to deal with the poop, you can burn it for heat and energy. However, you can also have the problem of soil erosion, water pollution, and loss of habitat because you may be cutting down trees which are, forests that animals and critters live in. And it's also not renewable if it's not harvested in a sustainable manner. So if you're cutting down the rainforest saying, hey, it's just biofuel, it's biomass energy, that's not actually sustainable. Let's take a look at geothermal energy. Geothermal energy basically means the use of the Earth's internal heat to generate power or heat. If you've ever seen a hot springs, it's the exact same concept. You take water and you pump it through the earth, you heat it up, and it comes back nice and warm and toasty. Some of the benefits, very efficient. You don't have to do any heating. The earth does it for you. It's also very low cost at favorable sites. And there's very little land use. And when I say land use, it actually talks about surface land use because everything happens underground. And you only have a moderate environmental impact. Some of the downfalls, however, scarcity of sites. Not every place is the same as Yosemite or Yellowstone that has really easily accessible hot springs. CO2 is still emitted. Noise and odor pollution is actually one of the biggest things. Your guests and visitors might think you cut the cheese a little bit too often when they smell that rotten egg smell that comes up from sulfur. And sometimes the cost may be too high except at the most accessible areas and locations so that only the choice areas will be able to use it. However, it's still a very good use of energy. Finally, we have hydrogen. This is one of the most controversial ones, the most hyped up ones in recent times. Hydrogen is basically an explosive gas that we can use to utilize to generate power. One of the most common methods is to use hydrogen fuel cells in cars. And one of the cool things about this is that there's almost zero pollution. When you're burning the hydrogen in your cars, you're actually producing water. The hydrogen interacts with the oxygen in the air and turns into water. Isn't that incredible? I mean, most people, when they see cars exhaust fumes coming out, you think, oh, it's got bad smog and all that stuff. But this car that runs on hydrogen only releases water. So some of the things, it can be produced from water. You don't have to try to go drilling it in the oils. You don't have to go try cutting down forests for it. You can make it with plain water, and it, in fact, is a good substitute for oil when it comes to powering cars. No CO2 emissions because you're only emitting water. Next, you got high efficiency, and it's easy to store. And it's safer than gasoline if you think about it, if you handle it properly. And finally, there are very little environmental impacts. However, some of the bad things about hydrogen fuel cells, you can't consider it to be renewable if you make it using fossil fuels instead of water. You can make hydrogen fuel cells with fossil fuel, however, you can't call it renewable because it's still fossil fuels. And it's also pretty dangerous, and the technology still hasn't really caught up yet. So that's hydrogen. And it looks like I've got 30 seconds left, so that'll be it for all this thing. Thanks for tuning in. Hopefully I get to reduce it down to these videos down to 5 minutes so I can cover everything in 5 minutes less. But that has been Renewable Energy Resources and Environmental Science Overview. Thanks for watching. If you like, comment and subscribe. But yeah, thank you. Oh, and for my class, notes, take them, and stop chewing gum. And take off your hats in class. It's rude. It's not classy.